So we have another problem here where we're changing between concentration measurements. So we're given the mole fraction and we're asked to find, we're given percent by mass. It says weight, but we're assuming it's mass in grams. And we're asked to go to mole fraction. So we have to remember that mass percent is equal to the mass of the solute over the total mass of the solution. So it's the mass of the solute plus the mass of the solvent times 100. And then mole fraction is very similar, but it's in moles instead of grams, and we don't use the times 100, we leave it as a decimal. So it's the moles of solute over the total moles. Moles of solute plus moles of solvent. So like we did with the other problem is if we know mass percent is 11.5%, we can go ahead and say, well, if we had a 100-gram sample, we would have 11.5 grams of solute per total 100 grams of solution. And then we can get the pieces that we need from that. So if we go ahead and want to find out about the solute and we're working towards mole fraction, we need the moles of solute. So from the mass percent, we'll take the 11.5 grams of the solute and convert it to moles. So it's sodium sulfate, and they're giving us the molar mass in the problem is 142.06. When we take the molar mass off the periodic table, it's okay to round to the tenths place. That tends to give us enough sig figs. In this problem here we have 3 sig figs with the percent, so it would be okay to use 142 or 142.1. But using that would give us the moles of solute, which would be 0.0810 moles of Na2SO4. And if we're getting the mole fraction, then we need the total moles. So then we have to find the moles of solvent separately because they're different substances. So again, if we have 11.5% sample, then 100 grams total solution, we have to subtract out the 11.5 to just get the solvent. So 100 minus 11.5 is 88.5, and that's grams of the solvent. And again, they tell us in here that there was water, so we're assuming again it's a water aqueous solution. So we're going to take the 88.5 grams of water and convert it to moles of water using the molar mass. And this gives us 4.91 moles of water. Okay, so we have moles of the solute and we have moles of the water, so we can go ahead and do the mole fraction. Mole fraction can be in relationship to the solute or the solvent. Usually if you're just doing mole fraction of a solution, it's in respect to the solute. So we're going to do mole fraction in respect of Na2SO4. However, when we do vapor pressure lowering, that colligative property, keep in mind it always has to be the mole fraction related to the water. So we're going to do moles of the solute, which is 0.0181, and then over moles of solute again, 0.0810, plus the moles of the water, the 4.91 moles. And again, we leave this as a decimal form. So this would be 0.01692 is the mole fraction, which is unitless in relationship to the solute in that solution. Okay, we're done. Thank you.